All right, so in this question, it looks like we're simulating some type of dice roll simulation. So we have an n-sided dice and an m-sided dice, and our goal is to count and display all the possible combinations of dice rolls that will add up to some target number, and the target number is entered by the user. Okay. Okay, so if we got a bit of a sample input and output here, so let's try to figure out what's going on. So if I had a 8-sided dice and a 12-sided dice, then it's looking for all the different combinations of these dice that will add up to this target. So a roll of 3 and 12 adds up to 15, 4 and 11 adds up to 15, 7 and 8 adds up to 15, and 8 and 7 adds up to 15. Okay, so that's important. So it's not distinguishing between, or it is distinguishing a different roll as like the two numbers. So if dice 1, 8 and 7 and 8, and dice 2, 8 and 7, those are considered different. So we need to display all of them. Okay. Same thing over here for a 15-sided dice and a 22-sided dice. Now, again, remember, we're looking at the input processing output version of problem solving here, and even trying to get these programs to kind of think about how to write them kind of chunking the main part. So if there's something we can get working first and then kind of modify that to see if we can kind of come up with a solution in pieces and test as we go, not just trying to write everything at once and hoping for the best. All right, so let's go into our problem solving and maybe see what we can come up with. The input's pretty straightforward, so that's just your m, n, and the target value. But before you even do that, we need to figure out a way to kind of permutate all the different possibilities, right, for the dice rolls on the screen, right? So if I have, let's do something simple so we can write it out. So let's say we have an n of 3 and an m of 4, okay? So if you were to write out all the different permutations, it's kind of like a little chart. So 1, 2, 3. So this would be like dice 1. Here we have dice 2. Dice 2 can go 1, 2, 3, 4. Okay. And if you look, so these, what we'd fill in the boxes here would be our totals, right? So like a 1 and a 1 is a 2, right? A 2 and a 1 is a 3, 3 and a 1 is a 4, etc. Okay. So, and so on. So 3, 4, 5, 4, 5, 6, 5, 6, and 7. Okay. So these are all the different permutations, right, that we can get. So how am I going, all the different totals, right? So those are the totals. So how am I going to generate that with a program easily? Because I'm certainly not going to use like a whole bunch of print statements and variables. So we've been looking at loops and if statements in our lessons. So when you want to get the permutations of something like this, what is happening is we can go through, it will start with like rows. It's kind of like a nested loop, I would say, that is probably going to work for something like this. So if we had like an outside loop, right, that deals with all the values for n. Okay, so that goes from 1 to n. And then our inside loop goes all the values from 1 to m. Okay? And if we were just try to maybe even print, see if we can get all these values to print out. Okay? So if we were to print, say, like n, m, and the total to the screen, that should generate all of these values. If you think about it, okay, so the outside loop starts first, n is 1, right? So, and m, then we go into the inside loop, m is 1. So we would, the first print statement would be 1, 1, and 2. So that's giving us that one, okay? So now the stupid keyboard keeps coming up. Now this n is going to stay at 1 because this loop's not finished. So m will go to 2. So we'll stay at 1, and then we'll go to 2, and it will output 3. So that's giving us this one. Okay. So m keeps changing. So the next one will be 1, 3. Right, and then it will do the 1 and 4. Okay, then this loop is done, and then n will switch. So it'll go 2, and then m will start back over at 1. So 2, 1, 2, 2, 2, 3, 2, 4. Okay, so just a simple loop like this is going to permutate all our options, and we can just print out the sum. So let's just see if that works before we do anything else. So we'll just go to my IDE real quick, and we'll just start dealing with that section, just so we can see if that works, or if our idea works before we try to figure out how to only print the correct ones. Okay. So I need an n, an m. So let's see, m. So we'll get that from the keyboard. N, maybe I'll do it in the other order. N, and then M. Okay. Oh, what am I doing? Shouldn't have changed my mind. Just making it more complicated for myself. Okay. Oh, we'll forget about the target for now. But let's just do our 2 loops. So we have dice 1. What did I say was going to represent n? So started at 1 in a while loop, while dice 1 is less than or equal to n. Okay. And then inside that we have dice 2 starting at 1, and while dice 2 is less than m. Okay. And okay, let's make sure we do our, and dice 2 would go up by 1 every time, and dice 1 would go up by 1 every time. So there's our 2 loops set up here, and then inside here we would just print out, let's say, dice 1, dice 2, and the total. Okay. My problem solving, I was using n and m. It should have been whatever the loop counter was going to be, right? Okay, so I think that would display all of our possibilities. Oh, you'll see what this happened. This is going to not work nicely, but say 3, 4. I haven't done total yet. Let's forget about total for now. I'm going to need something like this. Just remember when we were doing nested loops. Otherwise, everything is going to print in one line. So n is 3 and 4. Space. What am I thinking here? Let's just try that. 3, 4. There we go. Okay. I actually don't even need that. Brain shutting off today. Okay. So there's go. 1. So here's our one set of dice, and here's our other set of dice. Okay. And ooh, I forgot to put equals 2. So this is why it's good to test. 3, 4. Maybe we can get it right here. There we go. All right. So we got all of our first set, all of our second set, and all of our third set. It'd be pretty easy to deal with the total here. So total equals dice 1 plus dice 2. And here we can print out the total. So if we did 3, 4, okay, so there are all of our values. And now we just have to add in the target. So, so the user is going to get a target from the keyboard, some type of integer. Okay, and what are we going to do with that? So we need to check then whether the total is equal to the target. And if it is, that's the only ones we print. Okay. So we will check if total equals target. If it is, then we will print what's going on. Okay. So if we were to run that, oops. What did I do wrong now? Invalid syntax, dice1 equals 1. Oh, up here. Okay, so let's say my target value is 5, because it produces, there's a couple of them that will produce 5. Okay, so the only ones that are giving 5 are 1 and 4, 2 and 3, and 3 and 2. Okay, and that seems to be working correctly. And I think it said the program needed to also count how many of them it found. So I need a counting variable. So let's start it at 0. And every time we find one, we would increase count by 1. Okay. And let's just clean up our output here. So we need dice1 plus dice2 equals total, and I need to output it found count combination permutations. Okay. Ugh. There we go. Oh, this is not my video. Okay. Here we go. 3 and 4. Target value was 5. So this looks a little bit better. 1 plus 4 is 5. 2 plus 3 equals 5. 3 plus 2 equals 5. And it found 3 permutations. Let's check the inputs that they gave us in the problem. So they were 8 and 12. And the target, I believe, was 15. Okay, so it found 6 permutations, right? Which was correct. And 15 and 22. And what was the target? 17. So it found 15 permutations. So that is looking like it is working correctly. I believe that's what it said in our input. Okay, so what did we do? Well, inputs, okay, figured out what our inputs would be. We did some problem solving, right? We kind of figured out how this was working. We worked with chunking kind of our program, or testing one part at a time to see whether it was working correctly. And then we finished off our program, right, at the end. Right, we coded it up, right? We kept testing it as we were going along, right? Fixing any errors that occurred, cleaning up our output, making sure that our output matches the specifications of the problem.